We are going to see about the gamma distributions. Gamma distributions is nothing but a generalization of exponential distribution. Both the distributions are good models for waiting times. If you want to see, for example, when the two accident happens, if you see successive happenings of the accidents, then you are talking about the exponential distribution. If you are talking about the earth happening, then you are talking about the gamma distribution. For exponential distribution, the length of time interval between successive happenings is considered. That is, the time is considered till one happening. That is from A to B. A is the first happening and B the second happening. And between this, what is the time interval? This is known as the exponential distribution. But for gamma distribution, the length of time between O and the instance where earth happening occurs is considered. For example, that O is the starting. Okay, for example, morning you are going to see how many accident is going to happen. Then you are going to see the 10th accident, suppose. First accident, second accident, that is A, B, or 10th will be, earth will be the 10th accident. So if you are doing such way, such manner, then you are talking about the gamma distribution. But when R equal to 1, then the situation becomes the exponential distribution. It is same as the exponential distribution when R equal to 1, right? Now we are going to see about the definition. What is the definition of the gamma distribution? Okay, a random variable x is said to follow gamma distribution with parameters r greater than 0 and lambda greater than 0 if its probability density function is given by f of x equal to lambda to the power of r e to the power of minus lambda x to the power of r minus 1 by gamma of r. This gamma of r is nothing but the gamma function we have seen already. Here x is greater than 0 or 0 elsewhere. So PDF is nothing but lambda to the power of r e to the power of minus lambda into x to the power of r minus 1 by gamma of r. This is the PDF of the gamma distribution. And remember, x is greater than 0, right? And we are going to see some remark. The first remark is, it can be verified that, you can verify this particular thing. What you can verify? It can be verified that integral, this is true for all the distributions, right? That is integral 0 to infinitive f of x dx, okay, equal to 1. We will see how it has, how you can reach 1. For example, we will see the verification, right? What we want to prove? Integral 0 to infinitive f of x and integral 0 to f of x dx. That is integral 0 to infinitive. What is my f of x? Lambda to the power of r e power minus lambda into x to the power of r minus 1 divided by gamma of r into dx. What we will do is, we will make the substitution method. We will use the substitution method. That is, lambda into x, we will take it as y. Therefore, what you will get? You will get lambda times, what is x? Dx equal to dy. Okay, we have to change the limits, right? When x equal to 0, okay, what you will get? Y equal to 0. Okay, when infinitive means, of course, infinitive only will get. X turns to infinitive, y turns to infinitive. So our PDF will become integral 0 to infinitive. In the place of f of x, it will be f of y dy, right? So integral y varies from 0 to infinitive, x also 0 to infinitive, y is also 0 to infinitive. And then you will get lambda to the power of r. Okay, lambda to the power of r is one and the same. There is no change, right? We are not going to change. Lambda x only we have changed. So we can do like this. What is my lambda? Lambda is y by x. I can write y by lambda, right? So x I can write y by lambda, right? This x is there, no? X I will write, x is what? Y divided by lambda. Here I can write it down. X is nothing but y divided by lambda, right? So in the place of x I can write y divided by lambda to the power of r minus 1. Lambda to the power of r, there is no change, right? And e to the power of lambda to the power of r, there is no change. X I have changed into y by lambda, the whole power r minus 1, e power minus lambda into x. What is lambda into x? It is our y. Okay. Then gamma of r also no change. It will remain as it is. Then what is my dx? Dx will be dy by lambda. Right? That is my dx. Here, what is my dx? Dx is nothing but dy by lambda. Right? Now, very simple. So 1 by gamma of r is independent of this variable, right? It is constant. So it is out of integration. Okay, integral 0 to infinitive. Okay, and what is gamma to the power of r minus 1? Sorry, lambda to the power of r minus 1, that is in the denominator. Here you are having lambda to the power of r. Here denominator you are having lambda. So lambda to the power of r will get cancelled. Okay, this is lambda to the power of r minus 1. Okay, here lambda to the power of r, and if you take it in the numerator, it is r minus 1. So all the lambda gets cancelled, right? There won't be a term which is related to lambda. So what is remaining for us is e power minus y is remaining, right? And y to the power of r minus 1 is remaining, then dy. These are the things remaining. So rest and all gets cancelled. Then what is this function? Do you remember? We have seen the gamma function. Do you remember in the previous class? So this will be our gamma of r. Okay, divided by gamma of r. And gamma of r gets cancelled, right? So it will be equal to 1. Okay, this is by definition of gamma. How you got this? By definition of gamma function, right? That is how we got as gamma of r. So one more remark is, okay, what is one more remark? What is that? If x is a, normally we write now binomial variate, and how you will write same way. If x is a gamma variate, okay, with parameters. What are the parameters here? There are two parameters, right? R greater than 0 and lambda greater than 0. Okay? It is expressed as gamma, x is a gamma variate, no? X follows gamma distribution. There are two parameters, lambda and r, right? Now we'll see the C1. What is C? Okay, C is nothing but if Okay, if we put R equal to 1. So what you will get if in the PDF of gamma distribution, R will be 1 means, see the lambda to the power of R, e to the power of minus lambda x, x to the power of R minus 1 by gamma of R, where R we are taking as 1. So lambda to the power of R, okay, lambda to the power of R will be lambda to the power of 1. Okay, R is 1 now. E power minus lambda x, there is no R here, no change. Okay, x to the power of lambda minus 1. See here, sorry, R minus 1, I'm so sorry. X to the power of R minus 1. R is 1 now, 1 minus 1, 0. So R is 1, R is 1, we are writing R as 1, right? Divided by gamma of R. Can you see here? Divided by gamma of R. So I am writing it as gamma of R. R is 1, right? Gamma of R. So this is nothing but lambda to the power of 1 is lambda only, right? E power minus lambda into x. X to the power of 0 is 1. Gamma of 1 is also 1 only. And here it is x greater than 0. What is this? This is nothing but our exponential distribution, right? Which is probability density function of exponential distribution. When r equal to 1, you are getting the exponential distribution. Okay, hence exponential distribution, the very important concept is, okay, very important concept, that is, hence you can write exponential distribution is a particular case of gamma distribution. When r equal to 1, gamma distribution turns to exponential distribution. Now we'll see the D1, remark D. Okay, what is the D about? It is very simple. Now we have taken R as 1 now, right? We have taken R as 1, we will take lambda as 1, right? If we put lambda equal to 1, we have f of x equal to e to the power of minus x, x to the power of r minus 1 by gamma of r. We have taken lambda as 1. What it is? So here lambda is 1, all will become 1, right? E to the power of minus 1 into x. So only e to the power of minus x will remain. X to the power of r minus 1. So this will be 1. This will be 1. Okay, 1 to the power of r is 1. And e to the power of minus lambda is 1. E to the power of minus x. X to the power of r minus 1 gamma of r. Right? That is what we got here. Right? For x greater than 0 and r greater than 0. That we can call it as x is a gamma variate, okay, with only r is there, right? This is single parameter, and it is known as gamma distribution with single parameter r. And this gamma distribution is widely used. Okay, we are using this gamma distribution in many cases because it is only a single parameter, right? So the single parameter gamma distribution is widely used, and here lambda equal to 1.